Okay, now we're going to be solving triangles that are not right triangles, non-right triangles. And what you're learning today is the law of sines and the law of cosines. So here's the deal. And something you'll just need to learn. So here's the relationship. The sine of angle A is to side A as the sine of angle B is to sine of angle B is to B. And each of those ratios also equal the sine of angle C to side C. So they set up these great relationships. And this is if you're trying to find an angle measurement. And if you flip all of those, this is when you try to find a side measurement. So you just put the side of A over sine of angle A, and all of those ratios equal each other. But this is important. This works primarily when you have an angle, a side, and an angle, angle, side, and when you have side, side, angle, it will also work. But notice, if you spell that backwards, yep, you have to be really, really careful with this one. I'll go ahead and explain why. Okay, so when you're given this situation, and this is what that would look like, you're given an angle and then two sides, and every time, just set it up this way. Here are the three scenarios, the possibilities. When given angle, side, side, so maybe I should angle, side, side, angle, side, side, angle, side, side. When you're given that information, here's the three possibilities. When side A is greater than side B, you're going to have one triangle and you're good to go. When side B is bigger than side A, and when A is larger than the height, this thing, you're going to have two triangles. Look at this. When this right here, when B is bigger and then A drops down, well, look at A could drop down there or A could drop down there. So you're going to have either this obtuse triangle, or let's make that go away, you're going to have this triangle right here. All right, then the third possibility is when B is greater than A, but A is shorter than the height. Look at that. Even if you get this close, the triangle does not exist. So those are the possibilities to think about. Okay, so now use this form when trying to find missing angles. So this is what we have. Oh, look it. We have side. This is interesting. We have a side, and an angle. And let's see. This opposite angle is bigger than the adjacent. So in this scenario right here, we have this one. Notice the opposite from wherever the angle is, the opposite is bigger than the adjacent. You're going to have one triangle. So this opposite side is bigger than that, so you're going to have one triangle. Well, then you just set it up. So we know angle C and side C, and we are trying to find the missing angle. So we're going to use these. So sine of angle C, which is 61 degrees, over side C, which is 23, is equal, well, we're trying to find measure of angle B, so sine of angle B is to side B, which is 9. Well, we want to get this by itself, so we're going to cancel that dividing 9 by multiplying. Remember to do this correctly using parentheses. Then you just type into your calculator, left parentheses 9 whoops, 9 sine 61, and then right parentheses, divide 23. And that's going to give you this decimal number. And remember, when you try to find an angle, in fact, I would hit store right there on your calculator, because you're not going to want to try to retype that in. And so now, if you hit second sine, so second sine, and then hit second store on your calculator, enter again, and look at, we take the arc sine of both sides, which is what we just did when we hit the second button. We get theta is equal to about 20 degrees, because the nearest tenth is there, so we could even write it like that. So the measure of angle B is about 20.0 degrees, just like that. All right. And let's see, this time we're solving all of it. Okay, I'm going to stop this video and we'll go on to the next.